Good afternoon. Thanks for coming to this talk. My name is Yong Tang. I'm a maintainer of CoreDNS project. This is my GitHub handle, Yong Tang. By the way, in case you have any questions or you want to reach out to me, you can always ping me at GitHub. I should be available most of the time. In today's talk, I will spend most of the time discussing about CoreDNS project, especially about the CoreDNS deployment in multi-cloud and hybrid cloud environment. Before we get started, I want to introduce some of the background of CoreDNS project in case you're not familiar. As some of you probably already know, CoreDNS is a CNCF graduate level project. It's a flexible DNS server written in Go. It has a focus on service discovery. One of the great strengths of CoreDNS is that CoreDNS is plugin based. That means it can be easily extended for additional functionalities. If you have any new feature or any new functionality you cannot see in the out of the box, you can always add by yourself if you know how to write in Golang. Another strength of CoreDNS is the memory safety. As we all know, CoreDNS is written in Golang. This actually put a great advantage of CoreDNS compared against some other DNS servers such as Bind. We know Bind was written in C language. Although Bind has been used many years and has been mature and stable, from time to time, we see security vulnerabilities popping up. And this is because of the fundamental issue of C language. Compared with Bind, CoreDNS is fairly memory safe. In fact, several years ago, when Q53, which is a security audit company, performed a security audit against CoreDNS, they almost immediately switched the focus from memory and buffer overflow to DNS-related issues because they noticed that with Golang, there's not a lot of security vulnerability to scan for. CoreDNS itself is started and led by Mick Gibbon. When Mick started CoreDNS, CoreDNS was actually named as CaddyDNS. Obviously, that's because CoreDNS at the time was a fork of Caddy HTTP web server. Over the years, CoreDNS and Caddy has decoupled gradually, although there are some common infrastructure remains. For example, and most importantly, the plugin-based architecture still comes from Caddy web server. Some people may ask a question, we already have DNS servers and people have used DNS server for a long time. What's so special about CoreDNS? The strength of CoreDNS is it's cloud native. By cloud native, that means CoreDNS has many features and functionalities that's very much tied to the cloud native ecosystem. For example, CoreDNS has extended DNS protocols, such as DNS over TLS and DNS over gRPC. As you might notice, gRPC protocol is RPC protocol that is used very widely in many cloud CNCF projects. Things like Kubernetes itself heavily utilize gRPC. By utilizing gRPC, CoreDNS essentially behaves the same in cloud-native ecosystem. Another big point of CoreDNS is that CoreDNS is a default DNS server in Kubernetes. As some of you probably know, CoreDNS has been used in Kubernetes. As some of you might already know, CoreDNS has been shipped as part of the as some of you might already know, CoreDNS has been shipped as a part of a Kubernetes distribution since several versions ago. And if you use Kubernetes, you are going to use CoreDNS for your service discovery. In CoreDNS and Kubernetes, the default mode for deployment is the so-called in-cluster mode. In in-cluster mode, you have CoreDNS deployed as as a Kubernetes service by itself, and all other services will depend on CoreDNS service for service discovery. But some people may not know that CoreDNS can actually be deployed out of the cluster as well. That means you can actually set up CoreDNS outside of your Kubernetes workload, and it still allows your Kubernetes cluster to communicate to CoreDNS and serving service discovery functionalities. We are going to discuss about out-of-cluster deployment for CoreDNS allowed in this talk because that's an essential component to make a multi-cluster and multi-cloud deployment possible. Another interesting point of CoreDNS is the cloud integration. CoreDNS has many cloud integrations for several vendors. We have AWS Route 53 support, we have Google Cloud DNS, and Azure DNS support as well. The reason we have a fairly good cloud integration is that this allows CoreDNS to behave as a front end for many backend DNS record. Imagine you have a CoreDNS server, and you can think of a backend of different cloud vendors such as AWS Route 53 and Google Cloud DNS. That will be very much useful because you have one central location to divert your service discovery tasks. Let's get a closer look at the Corefile. Corefile is CoreDNS way of configurations. It essentially is a file in a very simple format. And the CoreDNS design has been in a way such that we try to reduce user knobs as much as possible. And because of that, inside the Corefile, you can achieve a lot of functionalities with just several lines. As you can see, in this simple Corefile, you only have around 10 lines of configuration, yet it evokes many plugins. The first plugin we use, that's the Kubernetes plugin, which I'm sure most of you guys probably already use that if you ever use Kubernetes. The second plugin, that's Route 53, which allows you to sync up your Route 53 DNS record on AWS. The third plugin we use here is the host plugin. Host plugin allows you to add additional inline record. We are going to discuss that fairly shortly. You also have health plugin for health check and Prometheus plugin for monitoring. And finally, you have the forward plugin, which essentially tells CoreDNS to forward any DNS that has now been handled to another DNS server, such as Cloudflare, or maybe just use Google public DNS to handle any additional DNS queries. Let's give another example about plugins. Let's shrink down the Corefile into only two plugins. One is the host plugin, another is the forward plugin. In this profile shows you how to make this happen. The forward plugin is passed with a value of 8.8.8.8. This means all the DNS query by default will be forwarded to Google public DNS. And then we have the host plugin, which here we only add one line. That is, we add inline DNS record of www.example.org to point to 192.0.0.100. And that's it. That's all you need to do to make some interesting DNS applications. When you run CoreDNS with this Corefile, you can check the DNS query with a dig, and you can see from the bottom of the screen, if you type type dig www.example.org, the return will be the record you pass through in your Corefile. So this one example might be too simple, but it gives you a lot of possibilities. Just imagine you are IT admin and you have a fairly big organization with, let's say you have 50 DNS records you need to add. But you're not very familiar with DNS protocol, and you're not even sure how to handle the different format in DNS zone file. So what you could do is you just add a fallback plan of pointing your DNS server to forward the queries to Google Public DNS, and for any internal DNS record, like your database server address, like some internal documentation site, you can just add a record inline in your Corefile with one Corefile and the CoreDNS. This gives you the ability to manage the DNS system in a fairly decent organization. Of course, we are talking about a small number of DNS records, but interestingly, some people prefer to do it this way because that allows them to bypass all kinds of complicated configurations. They don't need to learn different grammar of complexity. In a couple of years ago, I believe, or maybe like 1 year ago, there is a use case from one user in GitHub. He actually asked a question, and the question was that he used the host plugin to host like tens of thousands of DNS records, and he is still able to do that. By these tens of thousands of DNS records in host plugin, you probably get a sense of how big the DNS, how scalable CoreDNS could be, and how useful and easy CoreDNS is. We talk about for the plugin. Of course, that's a default mode, and you can directly use that to forward your traffic to Google Public DNS or maybe Cloudflare. But sometimes you want to add additional security. The reason you want to add additional security is that DNS by itself, by default, use UDP protocol, and the UDP, as we all know, are not very secure. So what if someone hijacks, fake some packet and fake some DNS replies and poison your DNS server? You want to establish some secret connection to make sure the traffic are coming from your CoreDNS server and connect to the Google Public DNS in the most secure way. Of course, you can achieve that with DNS over TLS, which is a functionality supported by CoreDNS out of box. With DNS over TLS, all you need to do is add the prefix of TLS, and that's it. From the Corefile on the above, you could see you add the TLS colon / and all the traffic will be connected. All the DNS query will be forwarded to Google Public DNS in a secure way, and you have nothing to worry about. Of course, this is just one scenario. Sometimes you may want to use your CoreDNS to serve traffic, serve query that only coming from DNS over TLS. And there are some reasons for that. While internally, you can assume the network is secure and safe. Externally, let's say you have a laptop outside of your enterprise outside of enterprise network. When you actually could allow your laptop to connect to a DNS, CoreDNS, and start asking CoreDNS to serve as a DNS server, even though let's say you're working from home, and this is a very good scenario to work with. In order to make CoreDNS to serve DNS over TLS queries, all you need to do is prefix TLS at the beginning of your Corefile, and you achieve your goal already. By the way, Apple just recently announced that they are going to support DNS over TLS out of box for the next release of macOS. So this could be interesting because with with CoreDNS, I think we might see some additional usage of CoreDNS for serving DNS over TLS in the future, combined with the trend of moving DNS into a more secure way with TLS. Next, we are going to talk about service discovery. A lot of people say, okay, what exactly is service discovery? Service discovery is a way such that when you have multiple services, you want each service to be able to locate each other in a homogeneous way. The reason we talk about homogeneous way is that your service, even though we talk about Kubernetes all the time, a lot of time you still have services located or scattered around different locations, different systems. You might have a service that's actually on AWS, and you may using AWS provided managed service like managed Kafka, because it doesn't make sense for you to manage some stateful services yourself if your company is not big enough. You may also have some service that's actually located on Google Cloud or maybe on Microsoft Azure. In that case, the service themselves are service records themselves are coming from different data sources. So how to do the consolidation? This is a challenge for service discovery, but that's also the place where CoreDNS has been doing pretty well. CoreDNS, the big advantage for CoreDNS is that CoreDNS is able to consolidate data from different sources. It can it can sync up data to AWS Route 3. It can sync up data for Microsoft Azure. It can sync up data for Google Cloud. But some people may ask a question, say, in this day and age where SDN is so easy and SDA is easily available in many places, do we really have a need for DNS? In fact, I was asked this question many times when I discussed with some of the folks in this area. And to me, I think DNS is still served as the best way for service discovery for several reasons. So first of all, DNS is a nice introduction. Even though with SDN, you might be able to assign a server or service with a fixed IP address. You never know what's going to happen next. So maybe, for example, like in year one, all your services are deployed on AWS and you have an IP address. Now, next year, you may decide for some reason you want to move everything to your private data center, or you want to move everything to Google Cloud. It may not be so easy if all your infrastructure is IP-based. But with DNS, it's super easy to just change the DNS record so that the same DNS name will be mapped to a different IP address. This actually gives you much flexibility you need to counter anything surprising in the future. Another reason for DNS to be used in service discovery is that DNS is easy and simple. As we have shown in the past slides, CoreDNS itself is a system that has been designed with the philosophy of simplicity in mind. You can easily add a record, you can sync up different sources, and it can be easily deployed in many formats. Another thing we want to discuss about DNS as usefulness is because DNS by nature is distributed. It may not be the most sophisticated distributed system, although it scales pretty well and it's massively scalable. We all know DNS scales to internet because that's how internet works, and that gives you a sense of why DNS could be a good solution in an easy way to solve a distributed system. And finally, another reason for DNS to be used in service discovery is that DNS by itself is very pervasive in IT infrastructure. DNS has been there in many years, and over the years, a lot of things change, although DNS pretty much remain the same. So in any IT infrastructure, you could see DNS all over the place, and your system can be easily integrated into existing IT infrastructure, no matter how legacy that could be. So let's recapture the Corefile we showed just a moment ago to revisit why CoreDNS could be a good choice. In this Corefile, we invoked many plugins, but I want to point out one more thing. Those plugins actually consist of at least 4 different data sources. The first is a Kubernetes plugin. That means you can think of the data saved in S3D, exposed in Kubernetes API server for your services deployed in Kubernetes. The second plugin, Route 53, this plugin allows you to easily connect the service managed by AWS on AWS Cloud. And the host plugin could be something in your IT organization where you have some random servers or big box servers sitting there standalone, serving some special need. And finally, you have for the plugin, which means all the other DNS queries will be processed by another DNS server. We use Cloudflare's 1.1.1.1 as an example, but this one can be replaced by any DNS server of your choice. We discuss about CoreDNS, and we want to get into the interesting part of multi-cluster deployment for CoreDNS. I'm sure many of you already know how to deploy CoreDNS in a standalone Kubernetes cluster. But what if you have multi-clusters? What if you have clusters that's located in different places? Like some cluster might be in your private data center, some cluster might be on AWS, and some cluster might be on Google Cloud. How are you going to make sure your services in one cluster can be accessible from another service in another cluster and behave just like one unified cluster? In order to achieve that, there are some requirements to make this happen at the networking level. So first of all your cluster need to have a non-overlapping cluster side lock. This is understandable because the IP address space has to be unique in order to allow one cluster to talk to another cluster. And secondly, any IP allocated within any cluster should be routable from any other cluster. This may not be so straightforward because many Kubernetes deployment assume the internal IPs are not visible, but you can still make this happen. Like you can certainly add additional route to your route table to allow traffic to be accessible from one cluster to another. Sometimes by changing route tables in VPC, or sometimes add additional route or switches as needed. And finally, multi-cluster deployment. It only works for headless service. The reason is that when we use standard cluster IP services, the cluster IP is handled by Kubernetes proxy, and obviously Kubernetes proxy cannot cross multiple clusters. If you truly make a module cluster to be managed by one Kubernetes proxy system, then essentially that became one cluster. So it loses all the benefit you try to all the benefit you try to bring in. So we are only going to discuss about the headless service, but even with headless service, it still gives you plenty of enhancement. We will discuss that fairly shortly. This is a standard in-cluster deployment, and that's the standard deployment model you're going to use when you have Kubernetes cluster in place. In-cluster deployment, CoreDNS will be deployed by itself, will be deployed as a service, just like any other service. The only thing different is that our other service will depend on CoreDNS to resolve the rest of the service. So there are some dependencies, but CoreDNS itself is deployed inside your Kubernetes worker node. But what we want to talk about here is the out-of-cluster deployment. Out-of-cluster deployment, by definition, is to move the CoreDNS outside of Kubernetes worker node. Not a lot of people notice that, but it is available in CoreDNS. In this diagram, essentially all you need to do is to move CoreDNS outside of Kubernetes worker node and make sure CoreDNS can reach the API server. In the Corefile itself, as you can see, you should add an entry called endpoint and specify the address of the API server. And that should be all you need to allow CoreDNS to sync up API server and get out the service record. You also need to specify cluster DNS of your Kubernetes cluster to point to CoreDNS IP address so that they could send the DNS query to CoreDNS. And that's it. That's out of cluster deploy. Why out of cluster deploy is important? Because this is exactly what you need in order to make a multi-cluster deployment. In multi-cluster deployment, you may have multiple clusters, and you want your CoreDNS to grab the service record from both API servers on two clusters. How to achieve that? The default Kubernetes cluster may not be able to reach that goal, but there is an external plugin called Kubernetes plugin. You can utilize this plugin to make the multi-cluster deployment available. Kubernetes plugin behaves exactly the same as the Kubernetes plugin. The only difference is the Kubernetes plugin. For Kubernetes plugin, you can specify as many Kubernetes clusters as possible, and you use endpoint to point to the API servers of each cluster. In this example, as you can see, you actually have two clusters. One cluster has API server 172.30.10.10. Another cluster has API server 172.30.20.10. You specify Kubernetes plugin twice. The first cluster, you assign a domain name of cluster1.local. The second cluster, you assign a domain name of cluster2.local. With that simple Corefile, you achieve the goal of allowing your service to talk to each other. But the only glitch is that your service is still separated. Each cluster has a unique base DNS domain, such that you pretty much just like randomly throughout adding some DNS record. And it may not be that interesting for many people, but there are some additional ways to make this thing interesting. With Kubernetes plugin, you can add a flow through line in configuration. With this flow through, you can have the same base domain name of cluster local for both clusters. With this configuration, as you could see, if a service is reachable within the same cluster, it will be reached. If it's not reachable, the CoreDNS will actually fall back to the second cluster and fetch the service for you. So that means if you deploy two services of the same name in two clusters, and that could serve as a fault tolerance, because you have two. You actually can, if your pod is going to reach a first, it's going to reach a service in the first cluster, and if it's not available, it will automatically point to the service in the second cluster This is an interesting case that could be very useful for many people. I'm going to fast forward this one, but if you are interested, you can take a look at the Kubernetes plugin and see how this can help you in fault tolerance for multiple clusters. Okay, we are a little bit running out of time, so I want to speed up a little bit and discuss about the hybrid cloud and multi-cloud. So what is hybrid cloud? Hybrid cloud essentially means you deploy Kubernetes both on-prem and on the cloud. This is an interesting situation where there are some certain situation you do want some of the service to be deployed differently. But by itself, hybrid cloud is no different than multi-cloud, where you have Kubernetes deployed all over the place in Google Cloud, in AWS, in your private data centers. This might be for different reasons. For example, you might want to always use a service, provided by different cloud vendors, or you want to find you want to combine the best service out of all in many scenarios. We do want to showcase to explain how CoreDNS handles cloud integration, because that causes a lot of confusion. In CoreDNS, people ask, how do CoreDNS talk to AWS Route 33? It's actually not through the UDP traffic, as many people believed. It's actually through the AWS Route 33 API endpoint. In this way, the traffic is done through HTTPS, which is much more secure, which also means you can carry the same authentication and authorization through IAM policy and IAM and policies and the rules. Because it's HTTPS, it's also much more reliable, because TCP is much better in error handling, and also it's TCP is connection oriented. Finally, with HTTPS, you can separate the data sync up and the DNS query into different channels, so they don't compete each other. As a final step, I want to showcase a demo, but because this is a virtual conference, I think it's going to be hard to show a demo. But I want to show a Corefile that you can play by yourself to see how to combine data from different sources and pretend to have only one front end as CoreDNS. This is the Corefile we want to show. You actually add three plugins. The first is the Route 33, which you can create a DNS zone on AWS and copy the ID here. This way, the domain name of CoreDNS.example.org will be handled by Route 33. The second plugin is CloudDNS, which you are going to do a similar thing, except the zone is created on Google Cloud. So which means CoreDNS, which means if any domain name that has now been handled by Route 33 will be fall through and handled by CloudDNS. The fall through is done through the optional fall through line in both in Route 33's configuration. Of course, you can also add a fall through configuration in CloudDNS as well. In this case, CoreDNS will find the next plugin to figure out how to do if they still cannot find a match in DNS record. You can certainly add a who am I, and or you can just forward to some other place. This will give you a case of you can have 3 machines on different places. And when you send a query to CoreDNS, if the machine is located on AWS, the returned IP will be on AWS. And if this domain is not available on AWS, you will get a reply from Google Cloud if it's available, or it might be some other places like like the 172.0.0.1 by whoami plugin, or you may just simply add a line to forward all the remaining DNS queries to some other place like your DNS server. And this is a very interesting play that helps you to design some interesting systems that make it really useful for your scenario. And all could be done with CoreDNS, which actually is a very simple and easy to configure DNS system that fits nicely in cloud native ecosystem. Okay, let me see. Okay, I think that's pretty much it for today's talk. If anyone has any question, you can certainly ask. I'll try to answer as much as possible.
I looked through the questions raised in the Q&A bar. So I think the first question is it possible to configure CoreDNS to consolidate 2 different external DNS servers, providing result for the same domain? The question, the answer is yes, it's definitely possible. If you look into some of the configurations presented, configuration samples presented in this talk, you probably notice a lot of the plugins allow you to specify an option of so-called fall through. The fall through essentially means if you have one plugin that's actually trying to do something, and this plugin cannot find the record from one backend, of course it's going to move to the next plugin, allow the next plugin to continue searching. So that should be possible, I think. Okay, let me see. The second question, which config option for zone management exists? Essentially, the CoreDNS server itself is more like a front end and serving the data record on the back end. The management of the data record are mostly handled in the back end by different plugins. For example, if your data are stored in a zone file, CoreDNS will merely just presenting the zone file as a DNS server front end. If you want to make any modification, you have to modify the zone file and restart the CoreDNS server. If on the other hand, your backend is from a dynamically managed source, for example, if your backend is AWS Route 363, in that situation, CoreDNS should be able to just constantly fetch the backend, and for any update, it will update the front end to present you the DNS record, present you the updated DNS record. Okay. The third question, where I can find the slide. The slide should be available on the schedule of the KubeCon link. If you still have trouble finding the slide, you can send me an email. My email is available. You can find my email from underneath my GitHub handle. My GitHub handle is Yong Tang, my first name and the last name. You should be easily find my email and send me an email. I will forward you the link so that you can find the slide. Okay. The next one, CoreDNS can transfer zone with other DNS servers. This is, as far as I know, we are actually trying to develop the zone transfer feature for CoreDNS. I think some progress has been made by some maintainers and contributors, I cannot remember if it's complete or not at the moment, but I can double check. And yeah, that's Philip. Yeah, Philip, if you still have a question, you can drop me an email or read the question in CoreDNS GitHub repo, and we should be able to answer that in more details. Another question. I understand that you deploy the CoreDNS outside the Kubernetes as external service. In this case, how do you deploy that? As I mentioned in the presentation, CoreDNS, when CoreDNS try to reach out to Kubernetes cluster and get all the information, all CoreDNS needs is the API server address. If the CoreDNS is located on the same server as Kubernetes API server, CoreDNS will connect to API server, get all the information needed. And the CoreDNS, of course, will expose port 53 as a UDP port. You can just set up your cluster DNS to point to the IP of the CoreDNS IP, and that should complete your deployment. In case you want to have multiple DNS servers serving your needs, you can certainly just locate different machines outside of cluster, and as long as the CoreDNS can reach to the API server, can reach to the API server, the CoreDNS IP can be fed into the cluster configuration as a DNS server IP. So like I said, even though in cluster deployment mode, CoreDNS can be considered as part of the cluster and as part of the service. But if you really jump outside of this concept, just consider CoreDNS as another static server, you should notice that CoreDNS can factory only need API server of Kubernetes, and you can reach CoreDNS, and your service will be ready to be served. Okay, another question that's interesting. Are you using private zones in your hybrid cloud example with AWS and Google? Yes, we are using private zones. Actually, you can use both private zones and private zones and public zones in any way you want. In fact, there's one interesting case is that you may we all know in Google Cloud. In Google Cloud, you assign a zone to a VPC, but Google Cloud actually allows you to not assign a zone to a VPC, and your zone is not accessible from anyone. But the record is still there, and you can see the record. In that case, if you deploy CoreDNS, and the CoreDNS is able to access the Google Cloud API, actually, you can just serve your DNS record, which should be inaccessible inside Google, and you can just serve it to outside, maybe your private VPC or maybe your local machine. So in this situation, this is an interesting case where Google Cloud DNS is essentially just a database for your DNS record, and it's not doing anything else. And that's an interesting use case, so many people might want to use if they want to manage zones. Okay, let me see. Okay, I see there's no other question. Just wondering, anyone else have any questions I can answer? Okay, I think I answered all the questions. Yes, if anyone still has any questions, you can reach out to me or reach out to any CoreDNS maintainers in CoreDNS GitHub handle, and you can also drop out email to me. You should be able to find my email underneath my GitHub handle. Again, thanks for joining this talk, and appreciate the help and appreciate the questions raised during the talk. That certainly is going to improve, allow us to continuously improve CoreDNS. Thanks, folks. Have a great day.